Math 2, Unit 4, Lesson 1. We are on page 199 and we're going to start talking about mid-segments of triangles. So to start, we are going to look at the theorem. Okay? And so I'm going to read this to you and kind of talk through what's going on while you're not talking. Okay, so if a segment joins the midpoints of two sides of a triangle, then the segment is parallel to the third side and it's half as long. Okay? So right here it's telling you that this point D right here is the midpoint of this line. And so remember, if something's the midpoint, these little dash marks mean that each of those pieces are equal to each other. Okay, over here it says E is the midpoint of CB, and so this is a midpoint, and you know it's a midpoint because they did two dash marks on this side, so both of those segments are equal to each other. Bless you. If this is the case, so if these two sections are equal, and these two sections are equal, then this line that connects the two midpoints is parallel to that baseline. Okay, so that's what it's saying here. DE is parallel to AB. The other thing is that this DE is half of AB. So if I told you that AB was 10, how much would DE be?
5.
And so what did you do to get that value? You divided by 2. Okay? Now going backwards, if I said right here that DE was 5, could you figure out how much AB is?
Yes.
Yes, what would you do? Multiply by 2 and you get the value of 10. Okay? All right, we're going to move on. And you're going to turn over to page 200. And we're going to look at why this works. Because it's always fun to know why. Okay. So, step 1 in figuring out why this works is you need to know the midpoint formula. I would highlight and circle this because you will end up using this later. Maybe not today, but in the future. So, your midpoint formula is where you're adding two x values and dividing by 2, and then adding two y values and dividing by 2. So if I'm trying to find the midpoint of this line right here for AC, C, the ordered pair at C is 0, 0, and the ordered pair at A is 4, 6. So to find the midpoint, you add both of the x values together. 0 plus 4 is 4, and 4 divided by 2 ends up giving you 2. In order to find the y value of the point, you add the y's together. 0 plus 6 is 6. 6 divided by 2 gives you 3. So the midpoint D right here is at the ordered pair 2 up 3. Okay, and you would do the same thing for CB. So if you're on line CB right here and trying to find the midpoint, you're adding the x values 0 and 6 divided by 2, which is 3. And then 0 plus 0, which is 0, and 0 divided by 2 is 0. Okay, and so this ends up making your midpoint E. Once you have that line, in order to check to see that these two lines are parallel, how do you do that? How do you know if something is parallel? How do you know if two lines are parallel? What does it mean? They don't touch, but more specifically, Bryce. Exactly. Parallel lines have the same slope. So in order to find the slope of a line, you can use your slope formula, which is right here. And again, I'd circle or highlight that. So you have your slope formula. So if you have 2 points on the line, so if I'm looking at line DE right here, I have point D and point E. I can use my slope formula to find that the slope is -3. What's another way I could find the slope for that one a little bit quicker? Anybody besides Bryce know? what is slope actually? It's rise over run. So Bryce, what were you going to say? Count them. So if we're doing rise over run, this rises up 1, 2, 3, and then goes left, -1. So that's exactly what they have right here, 3 over, or -3 over 1, depending on the direction you go. But you end up with -3, because if you have 3 over -1 or -3 over 1, you still get -3, correct? Okay, so same thing, if you were doing the slope from A to B, if I count up, it goes up 1, 2, 3, 4, 5, 6, and then left 2. And 6 over -2 also reduces to what? So, do these lines have the same slope? Yes. So that means they are parallel. Okay? The last thing is showing that one is double the other. And in order to find the distance of that line, you have to use the distance formula, another important formula there. And so just with all the other formulas, if you have 2 points that you want to find the distance in between, you just take them and plug them into this formula. So you can see that one of the answers was root 10 and one answer was 2 root 10. Is this double this? Is 2 root 10 double root 10? Yeah, because 2 times root 10 makes 2 root 10. Okay, so now we're going to get into examples. Okay, so if you can, you're going to still be on page 200 here. Okay, so this part we're just talking about the parallel segments, because within this there can be multiple parallel segments. The first thing you need to do is draw a triangle. When they start talking about these things, draw the triangle. And this triangle is saying that it should be labeled X, Y, Z. As you read on, it says A is the midpoint of XY. So what do? Go to XY and we're going to make a midpoint. How do I show that that is actually a midpoint? What do I do to the little segments?
The dash.
Good, put 1 dash, because that shows that those two are equal. Okay, so then we read on and it says B is the midpoint of YZ. So here's line YZ. I'm going to make a midpoint, which we're labeling as B. And then what would I do on this one to prove that those two segments are equal? I need to do 2 dashes. The reason is because I know that these two are equal, but I'm not sure if they're equal to this other one. Okay? And then the last one says C is the midpoint of ZX. So we'll make a point here. We're going to label that C. And this time I would do 3 dash marks. Okay, after you have that, because all of these are midpoints, that means you have parallel lines, and all of these lines can end up connecting. And so you have multiple parallel lines in this because of everything that we showed back here on why it works. We know that any of the 2 lines will be parallel if it's connected to the midpoints on other sides. So one midpoint or one set of parallel lines I can see is that we have segment CA is parallel to segment ZY. Okay, I'm going to give you about 30 seconds to see if there's any other parallel lines, and then I'm going to pull some sticks for you to give me the answers. So feel free to get those answers and also talk in your groups. Okay, so I'm going to go ahead and pull a stick, and this person, I would like you to tell me another set of parallel lines that are here within this triangle. Okay, so Seth, you are the lucky one. Okay, so BC is parallel, and you put it as YA. Now it is parallel to YA, but since we're talking about this whole line, I would probably write that as XY. But YA is still parallel to that as well. But I'm going to write that as XY because I'm going to have the whole segment there. Okay, thank you, Seth. All right, so there's one more set, and Tanner, can you tell me that last set?
AB and XE.
Good, so you can see right here, AB, line segment AB is parallel to XZ. Do we have any questions on that? Okay, we are going to move on now. And if you can turn over to page 201. Okay, so on page 201, it says, what is the measure of angle VUO? So V to U to O, they are talking about this angle right here. And then they want you to explain your reasoning. Okay, I want you to kind of discuss this in your groups. Talk about what you know. Talk about what you see, and then we're going to share out. Okay, so first of all, what do you think the degree is? Anybody? Okay, if you said 65 degrees, you are correct. Okay, now, do you know why? Okay, so this is kind of like proof-ish. Yes, tell me, Caleb. Say that one more time. I'm not saying you're wrong. I'm just looking at what you're saying. Okay, that is true. It is true, but do you know why? Like, what is your theorem or postulate or reason how you know that is true? Not sure? Okay, Diana. Okay, I'm going to have you stop there first. Okay, so you said U is the midpoint, okay, of NO. Okay, that is important, okay? Because of that, and because the same thing is that V is also the midpoint, right? Of MO. Okay? So because those are both midpoints, we know what about line UV? Well, what we know is that UV, it's called a mid-segment. And because of that, we know what about the line UV? UV is parallel to what? To NM. Is everybody okay with that? Okay. Now, because these two lines are parallel, there's a lot of stuff about the angles we know. Such as there's like alternate interior angles, there's alternate exterior angles. So what type of angles are 65 and this one that was missing?
Same size interior.
No. Same side interior be like this one and this one. Starts with the C. They are corresponding angles. Okay? So I just want you to kind of understand the process as to how we know that. Okay? All right, moving on to practice problem number 1. It says identify 3 pairs of parallel segments in the diagram. Okay, we already did something similar. Okay? Now it's your turn to do it by yourself, and I'm going to pull sticks for each pair. Okay, so you're going to have 3 answers here. You have about 20 seconds to write it down. Practice problem number 1.
So FH is parallel. HK.
Okay, coming back. I'm going to pull a stick. I'd like you to tell me 1 pair of the parallel lines. Are we ready? Okay, Natalie, you're up first. Good. Okay, let's see here. GJ. So let's look at GJ. So GJ is right here, and it's parallel to, now we could write it as LK, but let's use the whole line. So we would label it as FK. Good. But LK is not wrong. Okay? All right. Next one. Cameron, S. Okay, so we have GL right here. GL is parallel to, very good, to HK. And so we can see here GL and HK. Those are parallel. Great job. Okay, last one. Wyatt. So we've done GJ, we did GL, which means we need, what? Good. So I'm going to start with JL, and then you said to HF. Very good. JL. So right here is JL, and then that's parallel to HF. Okay? All right. Number 2. Name the segment that is parallel to GE. Okay? 5 seconds. Shh. Name the segment that is parallel to GE. Nate S.
Yeah, let's go. What was it? On number 2, right?
Yeah, number 2.
GE.
So here's GE. What letter is this right here? AC, good. Oh, you were saying F. Okay, AC, yes. Okay, perfect. All right, side conversations need to end, please. All right, we are now moving on to page 202. I want you to look at problem number 2. Okay, I'm going to need help with this, okay? I think you guys are smart. I know you guys are smart. All right, so it tells me right here, AD is 6. Before I actually answer this question, based on that being 6, what else do I know? Good. And since DC is 6, do I know how much this whole amount is?
Yes.
12. Is there anything else that I know is 6? Good. Serena knows. FE is also 6. How do I know that?
There's a midpoint.
It's half of this long one. Exactly. And because of our midpoints. Very good. Okay. Any questions up to this point? All right. So now DE is 7.5. So DE over here is 7.5. Based on that information, what else do I know? Good. AF is 7.5. Good. FB is 7.5. And then I heard that AB is equal to 15. Okay. So now let's go see if we can answer all these questions. Okay. Value for DC. Cam, what is it? Perfect. DC is 6. Okay. Value for AC is what, Fernando? Value for AC. We just wrote this down. Here is AC. Do you see how we added 6 plus 6 and got, okay, good. Tough question. All right. Okay, EF. Okay, value for EF is what? Gianna. Very good. EF is 6. We can see right here is EF, and we already figured out that it's 6. Okay, value for AB. Jasmine. 15. Very good. Do we have any questions about any of those? Okay. Practice problem A here. Find the value of x. Now, with equations, okay, listen up. This is like the important part of the lesson, okay? Are we ready? Chase, you ready? Okay. Now, whenever you're writing an equation, you want it to be balanced. So that means you want both sides to be equal to each other. Okay? Are 5x and 45, could I set them equal to each other? No, they're not equal to each other. Okay? Because this one is 2 times as big as this one, right? So what could I do to write an equation where they'll be balanced? What could we do? Okay, what do you think, Caleb? Not sure? Okay, what do you think, Seth?
Couldn't you just times 45 by 2 and then do 5x and do that?
Well, if I multiply 45 by 2, that's doubling this line. And that wouldn't be right.
Divide 45 by 2.
Do you think divide 45 by 2?
Yeah.
Would that cut it in half and make it so it's equal to 5x?
Yeah.
Yes. In fact, there's 2 ways of writing this. So let's write this one time like this. 45 divided by 2. So if I cut this line in half, it'll be equal to 5x. Okay, did anybody think of a different way that we could have done the same thing? Caleb.
Multiply 5x by 2.
Good. The other would be if I doubled 5x. So if I multiplied this line by 2, then that would also equal 45. Both ways will give you the same answer. Which way looks better to you?
5x. 45 divided by 2.
Yeah.
Okay, I'll solve it both ways. So here we have 10x equals 45. And we get x equals, you can reduce here by 5 and you get 9 over 2, or it equals 4.5. Both answers are good. On this one, in order to get rid of the 2 in the denominator, what would I do? Multiply by 2, because that cancels that out. And so again, you get 10x equals 45. Divide by 10 to both sides. And we get x equals 9 over 2, or 4.5. Okay? Any questions?
So did you just ask to get the number to get to? You just take that out? No.
Since I had a fraction of 2, anytime you want to get rid of a denominator, you can either multiply by that number, or if there's multiple fractions, you'd multiply by the common denominator.
So how did you get the 2?
How did I get this 2?
Yeah.
Because I know that this line is half of this line. And so we divide it by 2 to get half. Okay. Moving on, turn to page 202. Okay. Oh, thank you. All right, based on the knowledge that you have, can I set these equal to each other?
Yes.
No. I have to do something in order to make them equal to each other. Okay, on your own. I want you to do this problem. I'm going to come around and look. Write down what you're doing. Solve. Yes. If you get an answer, raise your hand and I'm going to come check it. Good question. That's what we were just doing. It seemed like this we're not paying attention.
It's really easy.
Got it. This is not, this is like right, this is small. So what you do to make this you have two options. Divide by 2. Big one. Or you can multiply the 2 by 2. So this thing. Good. And these are
Dude, are you scared?
Yes, perfect. Okay, the answer was 12.5. So, even though, as soon as I start talking, like you hear my voice, that should be like, okay, I need to stop whatever I'm doing and look at Mrs. Alto. Okay? Some of you still took and you put x minus 4 equals 17. These two, even looking at them, do these look like they are the same length? No. So, if you had 2 of these lines, it would be equal to 17. So sometimes it's easier to double the x minus 4 and set it equal to 17. And sometimes it might be easier just to take this number and divide it by 2 to set it equal to the smaller one. So the reason why I'm multiplying 2 times x minus 4 is because 2 of these will end up equaling the 17. Do we get that?
Yes. Okay.
So don't forget that you have to distribute the 2 through. So we get 2x minus 8 equals 17. Add 8 to both sides. 2x equals what? 25, and we divide by 2 to both sides. The answer is either 25 over 2, or you could have changed that to be 12.5. Are there questions? Okay, we're going to try another one. Problem 3. And is this on page?
Next page.
203. Okay. So, thank you for being quiet. Here we go. Line CD is a bridge built over a lake, as shown in the figure below. What is the length of the bridge? Do you see how we have this length right here? My question is, and I'm going to pull a stick, okay? If I know this length, what can I do in order to get that length? That is my question. And I'm going to pull a stick. I can see that some of you know the answer. Diana, what would you do? Exactly. All we do is take that and divide by 2 to get this segment here in the middle. And when you divide by 2, you get 1,320, and that is in terms of feet. Okay, questions? Okay, we are moving on now. What? Say that again? And we're going to do this one, which is on which page? Same page. Okay, 203. Okay, a surveyor needs to measure the distance PQ across the lake. So we need to figure out this distance across the lake. Beginning at point S, she locates the midpoints of this line and also the other line. And then she is able to measure NM because this is on the ground. That's easy to measure. And she finds out that it is 78. So, how long is the lake? What is that distance across the lake? What would we need to do? Okay, Alyssa. Multiply by 2. 78 times 2, we multiply, and we get 156 what? Meters. Very good. Okay, lesson check. Numbers 6 through 8. So starting on 203 and going over to 204. Okay, number 6. Answer that, and I'm going to pull a stick for the answer. You have to be looking at your book. Okay, good. Number 6. Then you look at your neighbor's book. Okay, the answer to number 6 is what? Stone is not here. Tegan. Good. The answer is line NO. Questions on that? Okay, number 7, looking in your book. Okay, you kind of have to flip back and forth. All right, so what is my answer and what did you do, Maddie Davis? You got 23. How'd you get it? Good. 46 by 2 is 23, and that is perfect. Nicely done. And last one, number 8. I want you to tell me how to set up the equation first. How do I make it so that it's a balanced equation? Okay? What do you have to do to that? How do we write a balanced equation? Okay, tell me, Bryce. Good, so we'd write this as 5x plus 20 equals 20 times 2, which is just 40. Okay? And then we solve it. So we'll go ahead and finish this one together. We subtract 20 to both sides. 5x equals 20. Divide by 5, and we get x equals 4. Do you have a question, Tanner?
Yeah.
Yeah.
Could you have divided 5x plus 22?
Yeah, because you could have also written it as 5x plus 20 divided by 2 equals 20. And then you could solve it the same way. You get rid of your fraction by multiplying by 2. And then same thing, 5x plus 20 equals 40, and then you would solve it. Okay? All right, any other questions?